Hi, this is Jeff. I'm a product manager here at CloudNC, and today we're going to talk about how to do tool management in Autodesk Fusion with Cam Assist. So there are a couple basic ways to do tool management. You can either let CloudNC do all of the feeds and speeds for you based on the tools that are in your library, or you could program each tool specifically based on the feeds and speeds you want to run for that application. For example, if you want to run roughing at a certain feed and speed and finishing at a certain feed and speed with the same tool, you can set that up in Cam Assist using the cut data in the Fusion tool library. So we'll walk through that. Just so you know, the default method that we use in Cam Assist is a sort of a combination of the two. We calculate based on our own cutting data and cut parameters, and those values can be used in toolpaths if there are not values in the tool library that you would use to override the automatically generated ones. So let's look at how we set that up. We've got a part here in Fusion. The part is not that important, but it is available in the description if you'd like to download it. And let's look at Cam Assist for one moment. So I brought in a tool library here called Local Training Set. And I just pulled in some tools from the Fusion libraries that are available. And you can see in here, I've got aluminum as my material right now. I've got a couple different representations. I've got green boxes without borders and green boxes with borders. So without a border, that shows that there's nothing in the tool library. There's nothing that we've programmed in manually. And Cam Assist is going to use its cutting parameters algorithm to generate feeds and speeds for us if we use that tool. The ones with the blue border represent that there are values in the tool library. So just to see that a little more clearly, let's open up the tool library and have a look. Have that maybe side by side here. Get this arranged a bit better. So we can see that on the training set library, and I've got some tools here, all different kinds. But if I look at this one, this was from the Fusion inch tool library, cutting tool inch, and it already has some properties outlined in Fusion. These are just right out of Fusion. So if we look at something like the aluminum roughing, it's already given us feeds and speeds and surface speeds, and we can edit those to make them even more refined. So here we go. So we could, if we wanted to change that plunge feed rate, for example, just make it a round number, we could accept that change. And then we've got a new parameter for that tool. So we can do that for each tool. And then we've got some in here that aren't set. So the ones at the bottom here with the numbers. Let's look at this one here. The 1/16 ball end. It's just got default preset set. It doesn't have parameters set for roughing or flat finishing, anything like that, or freeform finishing in the case of a ball tool. We could add those in, and then they would show up as blue borders in the CloudNC Cam Assist tool use tab, but we'll just leave that for now. So what happens when we run with this combination of tools? Let's see what happens. So we'll hit run. We've got a basic toolpath or basic part here, so it shouldn't take too long to run in Cam Assist. Okay, so we've got our CloudNC Cam Assist complete. And there's still some generation happening in Fusion. We'll expand these libraries out, or these toolpaths out. And let's look at the first one here, the facing. So we can see that it's used this 2-inch diameter face mill. And if we look at the feeds and speeds that are used, click on Edit here. And we've got a spindle speed and a surface speed and a cutting feed rate set for that tool. So where do those parameters come from? It's a bit of a challenge to see where exactly we have to find this tool, since it's not numbered specifically. But if we look in the tool library, and we're going to look in that library that we just had, or the one that we just ran. But we'll look in the training set. So we've got two tools that could the one. It's probably this one here. Pardon me, this one. And we know that it's a default preset. So a default preset is going to use the cutting parameters data from CamAssist. So that's why when we look at the spindle speed here, 5,000, it doesn't equal the spindle speed we've got here. So where would that have come from? How would we see that in CamAssist? If we look at CamAssist again, so there it is there, that top one. It's got no blue border around it, so it's being all generated automatically. If we wanted to be more prescriptive and define those values more, we would go into the tool library, find that tool again, and make changes to the feeds and speeds. So we know that our spindle speed was quite a bit different from the default data that was in the tool that we brought in. Let's say that maybe in that case that was a tool manufacturer's recommendation. So we actually want to make this our default for that tool. So how to do that? We could just add a new preset. So we'll edit this, add a preset, and we'll call this, we could use the material, aluminum, in the American spelling, and then roughing. And we hit accept. And I'll hit close. So I'm going to reload CamAssist so that it refreshes that library view. It's not going to change the existing toolpaths that we've got here. We can do that after. If I look at that first tool, now it's got a blue border around it. It's saying that there is a preset in there for aluminum and roughing. It's going to use that. So you can see we started from not having a preset. We added it in manually. And then if we reran this again, it would apply the different spindle speed and other values from the value we copied into that tool. So why do we have it this way? The idea is that our cutting parameters data, it's based on a physics-based model and uses the dynamics of the tool. It's not a database lookup. It's actually modeling the behavior of the tool in a number of different situations. So we can use that as a starting point to generate feeds and speeds based on a tool library. So you don't have to go into your tool library and generate values directly. Typically, you're going to start your first experience in CamAssist using one of our built-in libraries. We have an inch and metric library, and these have values all set up for aluminum. So if I look at the inch library here, you can see it's got blue borders for everything for aluminum. Other materials, it doesn't have it. So if we pick stainless steel, it'll have the display without the blue border. Okay, so we recommend that you set up your tool management in 2 steps. Number 1, set up your tool library in Fusion. And then number 2, prior to your first few runs, make sure you go through that Tool Use tab in CamAssist and check things off. Remember that you can set tools in your tool library and in your Tool Use tab independently. And so you can have runs where something in the library is not being affected, but it's not being picked up in CamAssist. So let's work through that. So we've got our tool library open here, and I'll close that. And if I open CamAssist, I'm going to pick that training set library. I'm looking at the tool use tab. I can make this a bit bigger. So we have tools in here that they're all green. That means that they're available to CamAssist. We might say, in a case like this, let's just take this 1-inch bull nose end mill. We don't want to use it for roughing. So what do I do in that case? I could go into the tool library and take off that roughing parameter because it is in the tool library. I can tell that from the blue border. But I could say maybe just in this case, I'll turn it off. Or I could turn off flat finishing as well. So in that case, it won't take that tool into the processed toolpaths that CamAssist generates. I could also do it from the material. So if I turn this off, it's not going to use that tool for any of the applications. What happens sometimes, you might be a bit surprised because you don't have anything in your tool library for a tool, and then you're wondering, why is it picking that tool for roughing or flat finishing? In that case, you might see something like this down here, where it's picking this 1/2-inch flat end mill for roughing. And you might be a bit surprised because it's being done via the cutting parameters. So if that's the case, we recommend that you just turn these off, and then, or you can even turn that one off. And then even though that tool is in your library, it's not defined in your library for this material, you can ensure that it won't get picked by turning it gray in CamAssist. And this is a persistent setting. So if I were to cancel this now and then come back into CamAssist, look at that tool library again, those settings I just made have been saved. So from run to run, you might have to do a quick check of your tool use tab. Once you get it all set up, you have a good synchronization between your tool library and your tool use, you should be in a good path for tool management. So one other thing before we go is to find out more information about tool management. Don't forget to check the documentation pages. So they're here, and everything you need for tooling and your cutting parameters are all in the documentation pages. And if you need any further help, don't be afraid to click on the feedback and support link in CamAssist itself. Thank you for your time today, and stay tuned for more videos from us here at CloudNC. Thanks a lot.